Hello Year 5, this is your second arithmetic video for today. Hopefully you watched the fraction one that would have helped you to access some of today's new learning. So these are the questions that you've attempted. If you haven't answered them yet, then please do that before you watch this video. Okay, so the first one, again, we're moving on looking at fractions again, but taking that learning a little bit further. So we're looking at 4/7 add 5/7. Again, if you're not feeling really confident with fractions, please draw it out. It doesn't have to be divided completely perfectly, so long as you have that understanding that a fraction is dividing something into equal parts. It's quite hard to divide something exactly into 7. However, I've just remembered you've got your jotters at home, so you can use the squares. So to have a whole with these fractions, you need 7 parts. So when you're adding fractions like this, you do not add the bottom numbers, you don't add the denominators. When they're the same, that's telling you that both fractions are a part of 7 parts to make that whole. So then all we need to do is to add the 4 and the 5 together, which is 9. Okay, now that is called what kind of fraction? Yep, it's an improper fraction, and that is absolutely fine if that's what your answer is. However, last week we were looking at changing improper fractions to mixed numbers. So that's where you've got a whole fraction or some whole fractions, some complete fractions, and then some parts left over. So I'm thinking if I need 7 parts, okay, 7 equal parts to make a whole, out of 9 I can only get 1 lot, okay, because 7 out of 7 will give me my 1 lot, and then I've got 2 parts left over because 7 add 2 gives me that 9 as my numerator. So that is absolutely fine as an answer. That is even better as an answer because that's showing you can change, you can convert, you can change an improper fraction to a mixed number. Okay, so either of those answers would be fine. As I said, that one would be even better. Right, now we're looking at subtracting fractions, which seems or can be quite simple. So say for example if you had 5/7 take away 1/7, then that would be very easy to do because it would just be 5 take away 1, so it would be 4/7. Now when we're looking at this, we've got 2 wholes, okay, then we've got 3/5, and we're trying to subtract 4/5 from that. So if you look at that, if you're trying to take away 4/5, you've got 3 here. Okay, so if we subtracted those 3/5, we'd be left with 2 wholes. Now I would have taken 3/5 away, I need to take 4/5 away. So I'm thinking about 2 subtract that 1/5. So I'd have to break my 2 wholes up, keep 1 complete, okay, and then I'd have to think about my second whole as 5 out of 5. And if I was taking that 1 extra one away that I needed to take away, the answer would be 1 4/5. Now that's quite a lot to contain in your head. For some of you that would have made perfect sense. For others you would be going, what is she talking about? So the easiest way, okay, is to have a look at this and then to think about representing the fractions so you can actually see it. Now I wonder whether if you're looking at mine you're happy with what I've done. Because one of the things we talk about all the time is making sure that what we're writing down or what we're representing matches our question. So I've got 2 3/5 subtract 4/5. What have I represented here? Okay, hopefully you've realised that I've represented 2 4/5. Now that is not what I'm starting with in this question here, so I need to rub out one of them. Now it's right. Now I'm representing 2 3/5. So what I need to do is I need to then do exactly what I explained earlier. I'm going to subtract, I'm going to take away 3/5. Okay, and I'm going to look back at my question and think I need to take away 4/5. So if I've taken away 3, I just need to take away 1 more. Maybe choose a pen that isn't blue because then it will show up. So I just need to take away 1 more. So I'm going to cross that one out, okay, and then I'm going to look see what I've got left. So I've got 1 whole. Okay, and then I've got 1 2 3 4 out of the 5 of that whole there. Okay, so we ended up with the same answer, but hopefully it was much clearer for you to see with this one here. Okay, so again, if you can't hold that information in your head, you can't imagine it, make that extra special effort to represent it in your jotter and it will make much more sense. And the more you do it, the less you'll have to draw, but actually it's really important to have that visual picture in your head. Okay, so now we've got something multiplied by 1,000 equals 236.2. So if we were in school, I'd be asking you, what do you need to do to answer this question? Because it's harder because we've got the answer in terms of we know something times 1,000 gives us this answer. Normally, we're trying to fill this part in, okay? But what we would be talking about in school is that actually we start with the answer and then we work backwards doing the opposite, doing the inverse. So I'm going to start with this number, and instead of multiplying it by 1,000, I'm going to divide it by 1,000, and that will tell me the number that I started with. And then we can read back and make sure that it makes sense. So what I've done here is place value. You don't need to write all of this down, but again, if you're not feeling very confident, I would. So we've got hundreds, tens, units or ones. Okay, we call them the same thing. When I was at school, it was just units, but now ones is much more common. Tenths, hundredths, thousands, and tens of thousands. Okay, so I'm looking at that number there. I'm making sure that it matches that one there. And then I need to think about it. So instead of multiplying by 1,000, I'm going to divide by 1,000. Okay, so that means that my numbers are moving down. Okay, and I need to think about how many columns are my numbers moving down. So I'm looking at 1,000. It's going to give me a bit of a clue here. It's got 3 zeros, so we need to move each digit down 3 places. So I'm going to start with this 2 here. It's going to move down 1 place to divide by 10, 2 places to divide by 100. Decimal point never moves. I'm going to move it down another place. Okay, and that's my 3 columns that it's moved down. I'm going to put that decimal point in there. Then you can do it very slowly with each one, but actually you know the numbers stay in the same order. So you can get it completely wrong like I just have. You can just put the numbers next to each other. So it was 2, 3, 6, 2, 2, 3, 6, 2. So long as you get that first bit right, then everything else will follow on and will be fine. So it's stayed in the same order. I'm going to put a 0 there. You can do it without the 0, but actually it's much easier to see it, and when you're reading the number it sounds better. So 0.2362. Okay, that is your answer. Right, now we're looking at this number, 5,500 divided by 11. Now this isn't a coincidence. I've set this question because there is a link between the beginning of this number here. Okay, I'm looking at it and thinking actually this number started as 55 and it's been times by 100, multiplied by 100. So I can think about 55 divided by 11. So we go back to, as usual, trying to use something that's quite simple to help us answer something that's a bit tricky. So there are 5 lots of 11 in 55. Okay, in 550 there would be 10 times the amount of 11s. So it would be 50. Okay, so the number we're dividing by has got 10 times bigger, so our answer will be 10 times bigger. And then that will help us get the answer of 500. Okay, that was your answer. That's not a very good 0. Okay, so now we switch over to the other side of the board, and again we're looking at fractions. I spoke to you a bit earlier about the fact that when your denominators are the same, okay, when you're adding fractions together, okay, both of these fractions need 5 parts to have a whole, so our denominator, our bottom number, stays as 5. So all you're doing is adding, okay, 1 and 2. Okay, right. If we're looking here again, if you're not quite sure about that, you can represent it. So I've got this empty fraction grid. Okay, it's divided into 5 roughly equal parts. It's harder for me because I don't have squares. So I've got 1/5. Okay, and I'm adding 2/5 to it. What I might do is do that in a different colour to show you the 2 different parts. So okay, it doesn't actually matter which ones I've coloured in. Could have done my 1/5 there and then my 2/5 over here, it doesn't matter. So I've got 1 part and I've added 2 parts to it, so I've got my 3/5 there. Okay, again, subtraction is really good to keep practicing. I'm going to put that decimal point in straight away. 4 subtract 5. Now I can't do that. This is a slightly harder one, okay, and I've set this on purpose because we need to move the learning forward. Now I can't exchange with this column because there's a 0, so I need to exchange here. Cross that out and make that a 1. Now remember, you can only exchange between columns right next to each other, so the one I have exchanged needs to come onto this column, so it needs to be exchanged from the units, okay, to the tenths. I go back here, I still can't answer this question, okay, or this part of it, so I need to now exchange again, okay, and then hopefully it's a bit more straightforward. So I've got 14 subtract 5. Okay, now if I have got 5 and I'm going to count up, add on 10, I get to 15. I'm trying to get to 14, so it's got to be 9. Okay, however you do that, it's up to you. Then 9 subtract 2, I'm going to take that away. Okay, so sometimes with subtraction I'm adding, so I'm finding the difference. I'm counting up because I find adding easier. Sometimes it's easier just to take that 2 away, like this one. Right, I've got 1 subtract 9, I can't do that, so I need to exchange again. Okay, and that becomes 11 subtract 9. I'm going to count up 9 to 10 to 11 is 2. Okay, now it's much easier. 0 subtract 0, and then 5 subtract 4, so 102.79. Okay, what is half of 658? Right, this part is easy. Half of 600, remember you need to remember what the value of that digit is, not look at it as 6. And I'm going to do half of 8 is 4. Now hopefully you've looked at that and thought, I know why Mrs. PA has done that. It's because both of those numbers are even, so they're easier to halve. We looked at this last week. Okay, this 50 is quite hard to halve, so I'm thinking about what's half of 5, and I'm going to times that answer by 10 to think about what's half of 50. So again, I said to you last week, if you're halving an odd number and you don't know, think about the even number that comes before it, so that would be 4. So half of 4 is 2, and then half of that 1, okay, would be 0.5. So half of 5 is 2.5, so half of 50 is 25. Okay, so then all I'd need to do is to add those numbers together. So it'd be 329. Okay, right. If you have been watching and looking out for this, it has come. So the code word today is fraction. And if you send that to me, there will be 10 dojo points added to your score. Okay, it's really important you watch these videos. So I'm putting some little clues in, little sort of rewards in. So keep watching. And on any of your work today, if you send me the word fraction, you'll be getting 10 extra dojo points. Okay, so very quickly we're going to think about UDC. So I'm going to underline, Ben buys 2 cakes, a bottle of water and a banana. How much does he spend? Now most of that is really important apart from the fact that it's Ben. So 2 cakes, a bottle of water, okay, and a banana. So we know here that A means 1, and it's how much does he spend. So hopefully what you're thinking about there, we could draw it. And we could label it if we weren't sure, but I think for most of you don't need to necessarily do that. You need to imagine it rather than draw it. But if you were getting confused, then you could easily draw it and then label each of the parts we're adding together. So I'm looking here, and this menu is really helpful. So this menu, I would underline the whole thing because there's no wasted information there. So I've got 2 cakes. Now if I'm looking at 2 cakes, they're almost £2 each. So I could imagine that they're £2. Like I say, if I bought 2 cakes at £2, it would be £4. But actually I've had to add 5p to each of the cakes to make it worth £2 or cost £2. So I'm going to think about £4, I'm going to take 10p away. Okay, so I am then going to think, so £4 take away 10p, I know is £3.90. Now in a minute, if you're not so confident with money and doing it the way I'm doing it, I'm going to show you another way to do it. But I'm modelling for you a way that you could use sort of some easy addition. So rather than adding £1.95, it's easier to add £2. Then I'm going to think about, I'm going to also buy a bottle of water and a banana. So I need to add these 2 numbers together. So I need to think, what do I add to 85 to make a pound? So 85 pence, so there's 100 pence. So I need to think 85 to 90 is 5, and then 90 to 100 pennies or a pound would be 15. So I could take 15 pence off this and then make it a pound. And actually if I take 15 pence away from that, that leaves me with 20p. So then what I'm adding to that is £1.20. Okay. Now again, if you're not feeling overly confident, what I've hidden beneath will help you. So then I'm thinking, can I add those 2 together? So if I add 10p to that, it makes £4. So I'm going to take 10p away from that, and that leaves me with £1.10. So I'm doing £4, add £1.10. So if my calculations are correct, Ben spent £5.10p. Now if we move this down, okay, for most of you, this might be a more straightforward way of doing it. However, I'm going to move this up. However, it is really important that you start to do some calculations mentally, and then you can check with doing a calculation, but actually you'll get much more confident. And the key is looking at these numbers and saying, actually, I know that they're really close to the next pound, so I can use that knowledge to help me. However, if we want to be completely accurate, you can just do a sum. So 5, 10, 15, 20. Okay, then 9 add 9, so double 9 is 18. I'm going to add that 2, because 18 add 2 is 20. 20 add 8 is 28. and then I'm going to break this 3 up into 2 and 1. So 2 and 1 make 3. So 28 add 2 is 30. Add the 1 is 31. So at the moment, my answers match that one. 1, 2, add 3 is 5. So my answers match. So if you did that and you weren't completely confident, I would still do this just to double check, but this is a really good sort of thing to work towards. So then I'm thinking, how much change does he get back from £10? Okay, for the challenge. So you hand over a £10 note, your bill was £5.10. What money are you going to get given back? So again, I'm thinking I'm going to count up. So between £5.10 and £10. So I've got to add 90p, and that will get me up to £6. Okay, so I know that I'm going to get 90p back. That would take me to £6, and then from £6 to £10 is £4.90. Now you could do a sum if you weren't quite sure, which would be 10.00. Okay, subtract 5.10, but there would be quite a lot of exchanging there. I think it's much easier to do what I've done here, or do it on a number line. So count from £5.10 up to £6 and then up to £10. But that is your answer for the challenge. Okay, let me know how you got on. Have a good day.